Oh! Alright, I got it working. So, this is Precalculus Review. Units 10.1 to 10.3 with the extra proof problem on 10.4. Much of this is pretty simple. There are some harder topics on this. So we'll try. I'm not going to focus too long on the easy questions, or the easier questions. So if anyone has any specific question on it, I think with things like this, arithmetic sequences, finding the next 4 terms of each sequence, I think this is fairly easy. You find, essentially you divide, well, how you do this mathematically, you divide this term by the last term if it's a geometric sequence, and then you subtract this term by the last term if it's an arithmetic sequence, and then you just continue using either the ratio or the common difference. I think most of us are probably fairly confident with this. For these, find the next 4 terms, you just need to write it out. For find the first 4 terms, here you just plug in n. You just plug in n 1 through 4. I think that's also fairly easy, so I'm just going to skip over that without doing any questions necessarily. Okay, here find the specified term of each sequence. These are recursive sequences, so if you get a problem like this, you need to essentially just plug it in that many times. For example, this says 4th term, a1 equals 5, an equals negative 3, an minus 1 plus 10. So you would start with 5, and you would put it into this equation. That's going to give you negative 15 plus 10, for example. So it's going to give you negative 5. Then you put it back in. It's going to give you 25. Essentially do this until you find the 4th term, and that's going to be your answer. So this is slightly harder, but I don't think it's that difficult either. Alright, here's the first thing I'm going to do a problem for. So determine whether each sequence is convergent or divergent. Now convergent means that it converges on a single y equals. So for example, in this case we have a sequence that starts relatively large. Maybe it starts at around 12, but it approaches y equals 1. It can approach y equals 0, y equals 1, essentially whatever. Mr. Fisher has talked to us about visualizing limits as a horizontal asymptote. This is just the visualization of that. If you can't figure out from the problem, you can just plug in a very large number, though it's often a lot easier to see if it's in the denominator than if the n or the higher degree is in the denominator. Then you are going to have a convergent sequence. For example, in 19, in 27, we have a convergent sequence because it approaches 0 as the denominator grows faster than the numerator. And some of these others, like 20, like 24, where the leading degree in the numerator is higher than the degrees in the denominator, you're going to have a divergent sequence, which means that it essentially goes towards infinity. As you keep plugging in numbers, they continue to increase exponentially quickly. So that's how you figure this one out. Find the indicated sum for each sequence. So for partial sums, there are 2 ways you can approach this. Either, if you have the right calculator, you can go into, as you know, maths and summation, or if these are relatively low partial sums, you can just plug it in manually, no matter what kind of calculator you have. I think if you have the calculator with the summation feature, you should try and plug these equations in there. You can check them by doing it both ways. Some of these higher partial sums are going to be just a little bit more tedious to do manually, and it's also going to be easier to make a mistake if you're adding together 11 numbers, especially in something like this, which has a recursive formula. So if you make just one mistake, it throws everything off. And here, find each sum. These are going to be really easy to plug into the calculator. I don't even know if we're going to have a problem like this, because essentially these sums is just exactly how you would plug it in. Now, if you don't have a calculator that can do this, what you know is that it starts at the n equals on the bottom, and then it's the partial sum, essentially, of however many terms on top. So for this 37, it starts at n equals 4, and then it's the next 11 terms, so it's going to go from n equals 4 to n equals 14, and you're just going to add them all up together. These are not that bad, I don't think. And then in these, with the infinity over it, this is essentially just looking at the limit. So in both these cases, actually, we see that the n is an exponent in the denominator, so it's going to approach 0, but we need to use this equation, a1 over 1 minus r. Essentially, what you have to see with this one is you're adding 8 to 8/10 to 8/100ths. It's continually decreasing. It may be okay if you just approximate with the first couple terms, but this is the universal equation that you use for the unlimited limits. I'm not going to talk about it too much now because you do go over it in 10.32. Alright, I'm going to copy in some more questions from the ebook.
I have a question. So,
yeah.
We have the formulas like s of n equals n times a1 plus an over 2. Do we need that, or can we just plug stuff into the calculator and find it?
Well, you can plug it into the calculator. Sometimes that's going to be easier, like if you don't have the right type of calculator to do that type of problem, it's going to be easier. But I don't know if there are problems where you need to do that. There are some problems in 9.3 where you just need to know the formula, because you're not necessarily solving for the sum, you're solving for some other part of it, like n. But that's a relatively limited number. But I think it's good to know. Alright.
No. Wait, are you talking about the a of n equals, or the s of n equals a1 over 1 minus r? Or?
No, about all the formulas.
Oh, alright.
Because in 9.3 there's a section. It's a little bit of a short section, but there's a section nonetheless where it gives you a sum, it gives you a of n, it gives you a of 1, and it wants you to solve for whatever part, like n or a1. So it's good to know it for that purpose. Okay, I don't know why this image copied is so small. I guess I just gotta zoom in. Alright.
Oh, hello.
No, where's
Hello.
the pen? Okay, this is actually being annoying.
Well, this is like super open whiteboard. Look at this new tech.
Yeah, the pen disappeared. I'm having some problems with the new tech. Yeah. Wait, where did it go? What happened? Okay, I'm having issues. I might have to switch to open whiteboard actually. Either way.